This question is super confusing. Okay, so if you are confused, good. This is very annoying. But we have to learn how to use our confusion to our advantage. Okay, so if you're looking at a story and you don't know how to kind of sort through all that information, that's a clue that you can probably do a better job working backwards, right? Because think about it. Look at these answer choices. These numbers are a very clear piece of the story, right? They're the number of students in the class. So that part is understandable. The original story, not understandable, but the answer is. And so we're going to work backwards, and that's what guess and check is all about. So if you understand the result better than you understand the start, the question, the story, then try working backwards. And what it allows us to do is just focus on one piece of information at a time. Whereas if we wanted to solve this algebraically, we could create some equations, but we have to take all of the information and correctly and perfectly put it into an equation from the start. So if we mess that up, first of all, because it's algebra, we might not know that we've messed it up, but also just like it's so confusing that you might end up staring at this thing for a long time and wasting time trying to come up with the perfect equation. But guess and check lets us get started right away. So without further ado, let's assume that choice B is correct, okay? That's where I always start because it's in the middle, and if I'm wrong, I can adjust by going to a bigger number or a smaller number. All right, so B, 21 students. Well, what do I know about these students? Well, I know Mr. Cole has distributed to the students the beaker, and he's giving each student 3 milliliters of solution. So, okay, if each student gets 3, then I can just multiply by 3 milliliters, and I have my calculator, so this doesn't take long. That's a total of 63 milliliters. Okay. Now he's supposed to have an additional 5 after all of that. So there's a couple ways to handle this information. We can kind of factor that in right now and say, all right, that means he has a total of 68, and that's the value of n. Okay, the beaker contains 68, right? It's the 63 he's just distributed plus an additional 5, so that's 68. Now, there's a couple ways to handle this. This is the best thing about guess and check, is you don't have to just see it the one way. There's lots of ways to see it. What I might do here is say, all right, we also want to think about what would happen if we distributed the 4 milliliters to these 21 students. So 21 students times 4 milliliters, that is 84 milliliters. And it does say that in order to distribute 84, he's going to need an additional 21. So what I could do here is say, all right, well, let's take the 68 that I had before and let's add 21 to that. What do I get? 68 plus 21 is 89. Meaning that the numbers don't add up, basically. So he's going to have too many of the milliliters in order to make the math work out. This is very confusing, this part, but the main takeaway is that we're wrong, right? We have the wrong value of the number of students, so we know B is wrong. Now, it is tricky, I think, in this case to determine whether we need a bigger number or a smaller number. Basically, what we want to do here is we want to have more students so that when we distribute the milliliters, more of it is going away because each student is, there's more students to kind of distribute it to. If you guess wrong and go in the wrong direction, it's not the end of the world because you would realize that when those numbers don't work out and you would have to choose. So if you went towards A here, not a big deal, you'd figure it out. But we do really want to go towards C. So let's try it. Now, the good thing about guess and check as well is even when we're wrong, we're right because we found the process that we're going to need. So I'm going to still do the same thing. 23 students times the 3 milliliters. 23 times 3 is 69 milliliters. Plus the 5 extra that we're supposed to have is 74. And that's the value of n. But let's do the same thing we did before. I'm going to even switch colors. We still need to do 23 students times the 4 milliliters, and that is 92. And what's the difference between 74 and 92? Or better yet, if we add in those 21, 74 plus 21 is 95. Different, right? So that's the key, is this number and this number need to be the same, and they're not, right? Before, same problem. So C is also wrong. It's not enough students. So we got to keep going. And I guess one thing you could do to kind of help you realize that you're getting closer here is, what's the difference between 84 and 89? It's 5. What's the difference between 94 and 92? It's 3. We're bridging the gap. So let's try D. It's probably D, but right, we are guessing and checking. We have trouble understanding this situation, so we might as well do it and just kind of get to the end and prove our answer. So 3 milliliters per student for 26 students is 78 milliliters, plus the extra 5 gets us to 83. So that's my value of N. And now I have 26 students times the 4 milliliters, and that is 104. And so what happens if I add in the 21, 83, I already know, but 83 plus 21 is 104. Boom. Happy day. We got it, right? We proved it. So that's what we wanted to happen. And there were different places where we could have made different choices. There's a way to do this that involves more division instead of multiplication. There's a way to do this that involves subtraction instead of addition. Basically, the way that this particular guess and check is working is we're kind of moving two equations towards a middle. And so there's lots of ways of getting towards that middle, but that's a good thing for us. It means we have flexibility, and it should give you confidence in the strategy here, that you don't need to do it the same way that your neighbor is going to do it, because there's many ways to do it. And you'll see something, all right? You don't all have to see the same thing. You just have to see something, and because we have one number that we're working with at a time, we can just focus on one piece of information at a time, one step of arithmetic at a time. That is definitely, with some persistence, a very gettable, hard question. So if you can add this to your score, that's awesome, because most people are going to get this question wrong. Definitely, this is going to be a problem for a lot of people. So if you've got a system that lets you kind of push through that confusion, then yeah, you'll have a better score.